The second deterministic case in this chapter is retirement planning example. So let's look at an overview of the problem. So we have an individual who is currently at age 30 and currently drawing a salary of 50,000 per year, and the salary is expected to go up, hopefully. So let's assume that the expected annual raise will be about 2%, but it's uncertain. So this is a variable that we want to simulate. But right now in this chapter, we're going to assume that it's deterministic, and then we will do the simulation in later chapters. Then here is a decision variable. So how much contribution should the employee make? So right now we are assuming 10%, but that's a decision that we have to make after analyzing, setting up and analyzing the model. Okay. Now, employer match is a given variable, input variable, up to 7% match. Okay. Now, rate of return, again, this is an uncertain variable, so we're going to say expected rate of return. Let's assume that it is 3% above inflation rate, and once again this is something that we need to analyze, see what happens if the rate of return is smaller than 3% or larger than 3%, etc. Now, retirement living expense after retirement, now that's fixed at $50,000. Okay. Again, if an analysis needs to be made on that, that can be done also. Now, retirement age, okay, is a decision variable the individual needs to decide, and we are expecting that it will be somewhere between 60 and 65. So the model can be visualized in this fashion. Okay. And the outcome that we want to analyze is that after retirement, nothing is going to go into the account, but 50,000 is going to get out of the account. Okay. So how long will the retirement fund last after retirement? So that's the outcome that we want to look at. So the retirement fund is starting, okay, and initially, of course, you're not retired, so no. So previous salary, annual raise gives you current salary. Right. Current salary, the employee contribution and employer match, that determines the contribution this time, and it gets added to the fund, and then you have the return on investment that determines what will be the value of the fund at the end of the time period T. And then of course you go back and start over, and after retirement, okay, all of this goes away, okay, up to that, okay, and then you start withdrawing from the fund. You still have some returns coming in from the remaining balance, and then you go back. So this is the general scheme, and the model is, okay, so here is the model. Let's look at the model with Excel. Okay, so we have the current parameters. Okay, all of these are given. Okay, so let's go ahead and use that. Okay, and then these two should be currency. We don't need any decimal places. These three are percentage. Okay, and well, rate of return is also percentage, and we won't enter the text part because we need to be able to use it in computations. Okay, and then the initial fund is 0. Okay, all right. So this is how we're going to set up the model. So we start with age 30, right? And then, of course, every year, if you're a normal person, you will age by 1 year. Okay, all right. So this is how we'll finish up the column in just a little bit. Okay, and then you have a column for are you already retired or not. Okay, so we need this to be able to see whether your salary is going to stop, right? So right now the salary is 50,000. Now you're going to increase your salary at the rate of, so previous salary times 1 plus the raise, annual raise. Again, this is assumed raise now, and since we're going to be able to copy, we're going to do F4 to absolute reference. Okay. Now, as we copy this, okay, we want to make sure that this will be set to 0 once you retire, right? So there may be several ways of doing this. Okay, but one way of doing it is to multiply this with whether you're retired or not. Okay, so let's set up retired. Okay, so if, okay, your current age is greater than or equal to your retirement age. Okay, so retirement age is right here. Okay, we haven't entered any value there. We will. So that needs to be, we should be able to copy this. So let's make it F4. Then if that is so, then you're retired. Okay, otherwise you're not retired, right? So retired, if age is greater than desired retirement age is 1, otherwise 0. So let's right now put an initial value of 65, and that is a decision variable. So let's make it like that. So now we can copy this, all right, and we have to extend the model below. We will do that in just a second. So what we can do is, if we multiply this salary, right, by whether you're retired or not, right? So E15 times the increase in rate times, okay, if you multiply by retired, then you get 0 when you're not retired. So what you need to do is to do 1 minus retired. Okay, so 1 minus retired would mean that if you're retired, you'll get 1 minus 1, 0. So this product will give you a salary of 0. If you're not retired, then this value will be 0. So 1 minus 0 will give you 1. So that will give you your salary. Okay, so we can use this column to also set up the contribution, match, and total contribution. So contribution here is, well, we don't, the contribution will be 0 if the salary is 0, so that's not a problem. Okay, so you get the salary, right, multiplied by the employee contribution. Okay, so that's good. Okay. Now how much is the match? Okay, match is up to 7% only. Okay, so if your employee contribution is less than 7%, then it will be the employee contribution is what will the the match will be. So we need to model this in such a way that when we do what if analysis and we want to consider employee contribution that is smaller than 7%, then the model will be able to handle that. So we can say min of these two. So if this is 3%, then employer match will be 3%. If it is 10%, then employer match will be up to 7%. So we take the salary and multiply by the employer match, and that should be absolute referenced. Then we add the two, employee contribution plus match will give you the contribution.